Hi, I'm on Mohammed and I'll be teaching you thermodynamics. So today will be our introductory class in which you will learn some basic concepts of thermodynamics. So what is thermodynamics? Thermo means heat and dynamics means power. And in this course we will be learning how we will convert heat into power. So here we have a conservation of energy principle, and basically the most important thing here is first law of thermodynamics. What does that says? It says that energy cannot be created or destroyed, but it can change its forms. And this principle says that during an interaction energy can change one form to another. Now this is the first point, and the second point is total amount of energy remains constant, and the third point is energy cannot be created or destroyed. If you see the picture on the right side, it satisfies three of the conditions we just studied it. And how is that? First is we have a block initially at some height which contains 10 units of potential energy and 0 units of kinetic energy. But when it's going down, we can observe that some of the potential energy is being transferred into kinetic energy. So it satisfies our first condition. And for the second conditions, we can see that initially we had 10 units, and right now we have 7 units of potential energy and 3 units of kinetic energy. So if we combine both of them, it will also remains constant, because we have initial tens and right now we also have 10, 7 plus 3 units. And the third point was energy cannot be created or destroyed. So here we did not create any energy and neither we lost any energy. We just converted some of the energy, some of the potential energy into kinetic energy. Application areas of thermodynamics. So thermodynamics is widely used in power plants, to cars, in human body, refrigerator systems, anywhere where work is being done. So here we have some dimensions and units. If you see the table 1, these are fundamental 7 dimensions, and along with that you have their respective units. Apart from that we have some derived units. And what are derived units? So derived units are if we multiply or divide any two or more basic dimensions, and we will obtain the derived unit. So how is that? For example, you can see that we do not have velocity here. So how will we obtain that? We will obtain that by dividing length by time. So these both are basic units. So that's how we will obtain the derived units. So here we have two system, metric system and English system. Metric system is widely used because it's convenient, and it's more easy rather than English system, which is more complex. So here we also have some prefixes you need to at least memorize from nano till mega, because we will be using them in our numericals. So what is a system? System is a quantity of matter or region in space chosen for study. So if you want to study an engine, you must pick it and consider it as your system, and anything around that will be your surrounding, and anything which separates your system from environment or your surrounding, it will be a boundary. So here we have two types of boundary. One is fixed boundary and other is movable boundary. So a fixed boundary is like a container, like a closed container, and movable boundary is like a cylinder that has a piston which is moving up and down. So systems are also classified into closed system and open system. So closed system is a system which only transfers energy and cannot transfer mass. And apart from that, an open system is a system in which we can transfer mass as well as energy. In order to define your system, you need some properties, and properties are characteristics of a system. Some familiar properties are pressure, temperature, volume, and mass. And here we have intensive and extensive properties along with specific properties. So intensive properties are those properties who are independent of mass, such as temperature, pressure, and density. And extensive properties are those who are dependent on mass. And what is a specific properties? Specific properties are extensive properties divided by mass. So example of extensive property is volume. So if you divide volume by mass, it will become a specific property. And also we have enthalpy and internal energy. They are also extensive properties. If you also divide them by mass, it will become specific properties, which will, like, if for example if you divided volume by mass, it will become specific volume. And if you divide internal energy by mass, it will become a specific internal energy. And if you divide um, enthalpy, if you divide enthalpy by mass, it will become a specific enthalpy. So here we have density, which is equal to mass divided by volume, and its representation is called rho. So if you have some substance and that's density is greater than water, it will sink down. But if you have a substance that's density is less than water, it will float on the surface of water. So here we have specific volume. We just studied what is specific properties. So here we have specific volume, and it is, and volume is a extensive property. If you divide it by mass, it becomes a specific property. So here we have specific volume, which is inversely proportional to this formula. So we can say it is equal to 1 over density. So here we have specific gravity. By this formula, we can easily find specific gravity of any fluid or any substance. So specific gravity is a ratio of two densities. The first density will be of any fluid, and the second density is of water. And the density of water is well known, which is equal to 1000 kilogram per meter cube. And what is a specific weight? Specific weight is represented by a gamma, which is equal to density multiplied by gravity. So here we have a short numerical in which we have to find the specific gravity of mercury. So given is gamma. So we know the formula that gamma is equal to density multiplied by gravity. So if we divide the gravity on both sides, we will obtain density equal to gamma divided by gravity. So the gamma is given and we know the value of gravity. So if we divide both of them, we will get density. So by the formula of specific gravity, which is equal to density of unknown material or density of mercury divided by density of water. So we know the density of water, which is equal to 1000. So if we divide both of them, we will get this answer. So here we have a system at two different stages. So the first state is on the left side and the second stage after expansion is on the right side. So what is a state? State is defined as a set of properties. State and equilibrium. What is an equilibrium? Equilibrium is a state of balance, and we have four types of equilibrium. First we have thermal equilibrium. So thermal equilibrium is in which we will observe no temperature change in our system. And in mechanical, we will observe no pressure change in our system, and in phase we will observe no change in solid, liquid and gas. So in our chemical equilibrium we will observe that there will be no chemical change. The conversion from one state to another is called process, and it requires a path. And what's a path? Path is the series of states through which a system passes during a process. So when final and initial states are same, it is a cycle. In quasi-equilibrium process, our system remains close to an equilibrium state all time. So if you see the diagram, you can see that our system is very close, or our piston is very close to an equilibrium condition. But in the second diagram you can see that our piston is very far away from the equilibrium condition. So the first one is quasi process, but the other is a non-quasi equilibrium process. So here we have isothermal process in which the temperature remains constant throughout the process. So in isobaric process, the pressure remains constant throughout the process. In isochloric process, the volume remains constant throughout the process. Zeroth law of thermodynamics says that if two bodies are in thermal equilibrium with a third body, so they're all in thermal equilibrium with each other. So here we have some temperature scales. So what is an ice point? Ice point is at 0 degrees Celsius, and steam points are at 100 degrees Celsius. So here we have Celsius scale and Kelvin scales, which belongs to SI unit system, while Fahrenheit scale and Rankine scales belong to English unit system. So here we have some conversions. You need to memorize few of them. At least memorize the Celsius into Kelvin, and how you will convert Fahrenheit into Celsius. So you need to memorize at least two of them. So because we will be solving them in our numericals. What is pressure? We know that pressure is a force per unit area, and here we have unit conversions of pressures, like if pressure is given into bar, how you convert them into Pascal, and if pressure is given into atm, how you convert them into pascals. You may should memorize them. So here we have four types of pressure. First is atmospheric pressure. Pressure exerted by the atmosphere is called atmospheric pressure, while absolute pressure is the actual pressure at a given position. So what is a gauge pressure? It is the difference between absolute pressure and the atmospheric pressure, while vacuum pressure is the pressure below atmospheric pressure. So here we have two formula to find these pressure. If you want to find the gauge pressure, you need to subtract absolute pressure with atmospheric pressure, and if you want to find the vacuum pressure, then you need to subtract absolute pressure from atmospheric pressure. So here we have a problem in which we need to find the absolute pressure. So vacuum pressure is given to us, which is 40 kilopascal, and atmospheric pressure is given to it, which is 100 kilopascal. And we know that absolute pressure is equal to atmospheric pressure minus vacuum pressure. So if we subtract both of them, we will obtain 60 kilopascal,